Hello everyone and welcome back to my YouTube channel. So I'm Mayank Agarwal and in this video we are going to learn about different methods and functions which are available to us on a list data structure. So in the last video we covered everything about list data structure. If you have not seen that, please make sure that you see that from the I button, or I will pick the link in the description. So please make sure that you see that. And in this video we are going to learn about all the different functions and methods which are available to us in list. Now I told you when I taught you about data structure that each and every data structure basically has few methods and functions which make it, I would say, a lot more useful and which help us in performing some operation easily and a lot efficiently. So let's get started with list, and I will explain you exactly what is the difference between function and method, and how the properties which we saw, right? The properties which we learned about in the last video, how the methods are available for them so that we can use the same. Okay, so let's get started. So now let us begin. First, let us understand about functions on list, because functions are actually something which we have already been using, right? So we are using print function, length functions, and few other ID and all these functions. So functions, I think all of us are pretty aware that a function is there. Like let's say, for example, length function is there. In that you provide something, so it actually kind of expects an iterable. Now iterable I have already explained you what it is, and it gives you something based on that, right? If you will give valid input, which is let's say an iterable, it's going to give you the answer. If you are going to give, I think, integer like 1 2 3, then of course it's going to give you an error. So in a similar way, I would say these functions work on a particular list or any other data structure which we are basically, let's say, dealing with. So now let us learn about few of the functions which we have. So the first one is length. Okay, so to showcase you the length data structure, I think, so first let me create a list. So let's say L1 is equals to 1 2 3 4 5. Okay, so the very first one is length. So if I do L1 of length of L1, it's going to be 5. If I just do length of, let's say, an empty list, it's going to give me a 0. Okay, so it just tells you how many elements are there inside your list. Okay, so this again basically is very easy function, and it is inbuilt in Python. Like we have not created it, we are just directly using the same, and all the functions rather here are inbuilt. We are going to see about user defined function in the next module. Okay, like of course you can create your own function as well, but it is again very important to understand if already a function is present or not, right? For example, you can actually create your own length function. Like you can actually calculate the length yourself as well. Let's say L is equals to 0, and you can do like this for I in L1, right? L is equals to L plus 1, or let me say L size. Okay, not size, rather length is a better word. So list length. Okay, list length, list length. Okay, so you can do something like this as well. Now again, this is pretty straightforward, like it can give you an answer, but why would you do that if we already have a function for that, right? So that's where it is very important to understand what are the functions which are available to us at all. Okay, so like every video, the way I've been teaching you, I have given you the proper, I would say, documentation and things to refer for your exam, before your placement, internship, any, I would say, online assessment. So yeah, please make sure that you download them and use them as well. So the length function, as it has seen, it returns the number of items in a list. Okay, the next one is actually the max function. So next one is max function. Again, as the name suggests, if you're gonna give a list to it, it's gonna return you what's the maximum item there, right? So if you provided, let's say 1 2 3 4 5 7 8, okay, then whatever is the maximum item. Okay, so if I make, let's say, if I make here L2 is equals to some number. Okay, basically what it's going to do, it's going to give you the maximum item here. Though one thing you have to be very, I would say, sure of, that let's say inside your list, okay, yes, list is a heterogeneous data structure, that is true, but inside your list you have to make sure that items are the one which are comparable to one another. Now what I mean by comparable is that, let's say if you write A, B, C and 5, then again they are not something which you can compare, right? How can you say that which of them is bigger, right? Which, if max is bigger or L3, so it's going to give you an error because it tries to run this greater than operator inside. Okay, so basically same code it tries to run where it checks, okay, which one is greater. And if you are basically dealing with few of, I would say, items which are not comparable to each other, then of course it's going to give you an error. Okay, so that thing is very important to understand, that if you're using this inbuilt function max one, you can use that if everything is there which can be easily compared. Okay, so if all, I would say, numbers and float, integer and float are there, you can use that. You can actually also use two strings. I think I've already told you this as well. So I think you should be good to tell me the answer, whichever which one is bigger, right? So it's giving ZVC because we have seen that how strings can be compared, right? Lexicographical comparison. Please make sure that you see the, I would say, operators video there. So relational operators, I've explained that very nicely with steps. So that is also fine. But yeah, the second you have, I would say, elements in the list which cannot be compared to each other, then it's a problem. Okay. Similarly, minimum is a function. So minimum just in a similar way tells you which thing is minimum. Okay. So yeah, something like this. Minimum is L1, then minimum L3. I think we defined L3. Okay, let me do L2 because L3 again the same issue. If you have a string and a integer or float, like things which cannot be compared, then it's not going to give you the answer. So minimum L2 is going to give you this answer, and minimum, let's say L3, or if I just copy this, it's also going to give you the answer, right? Min. Okay, so inbuilt function which we can use very nicely, and it just tell you whatever is the minimum in your list. Okay, next one is sum. Okay, again very straightforward and I would say similar understanding. It gives you the sum, so I can get the sum of L1, L2. Again, the second I try to get the sum of L3, it's a problem because integer and string cannot be added. On a similar load, let us try to get the sum of this ABC and let's say DEF and sum of L4. Okay, again it's a giving an issue. Sum of L4, yeah, because this is not like, it is not adding it in this way, right? It may be taking 0 in the starting, it may be taking 0 in the starting and trying to add that. So don't ever get confused that okay, it is just adding your elements, and if you add it, let's say string or something, there it is not concatenation, right? The approach which we have in our mind is that okay, it's gonna sum all the things. Okay, the plus, or I would say this operator, okay, in your overall Python, it just concatenate things for strings and I would say list, but that is not what sum does. Okay, it's actually I think something like this. So it must be showing some answer, and then for I in I would say L4, it must be doing answer is equals to answer plus I. Okay, or maybe let's say in I think it's I only. I don't think it is int of I as well. So maybe we can see it here. Yeah, it's I only. Okay. So yeah, if it is having integer, then if it is having string, then it's a problem. So you have to understand these intricacies very well, because again, this can be asked in an interview in the very initial rounds, or someone can give you a question, like some company has, I would say, a test where they are trying to see how much you know. And in an MCQ question, you can very well get easily confused with that, right? So the next one again is sorted. So I think kind of very straightforward to understand. Sorted of L1. Okay, just gonna give you the thing in sorted manner. Again, if you tell it something which cannot be compared, integer and string, then it's a problem, right? If you are giving it, L4 can actually be compared. So L4 can be given as an answer because see, this is two strings, 3 and 4, and we know that lexicographically string can be compared. So here comparison is getting in place into the picture. So this is your overall, I would say, sorted. Okay. So sum, min, max, length, and sorted. I think these all are very clear. Again, you have the proper documentation here as well. Just that anywhere you will find these documentation, or if anyone has explained you, he will not go in depth and explain you where it fails. And that is, I think, what is tested in all the assignments, and I would say in any interview. And that is where I feel that, you know, even after knowing these concepts, students struggle a lot. And that is what I'm trying to basically make sure that you don't do, right? Because it is very easy to just tell them on, I would say, on a very high level, right? So sum gives you a sum, but then why is it failing here? Why is it failing for this? That is something which you have to always understand and remember. Okay, cool. So let us now see the next one. Next one is any. So okay, so it returns true if any of the item in the list is true. If the list is empty, it returns false. So I think I told you already that what are different things which are false, right? So false, I think I told you that empty list 0, 0.0. Okay. All these are actually false values. So I think you remember that. I think none was also there. So just you can see that in the Boolean when I explained you the Boolean thing. Now, if your list, okay, so let us try to understand this intuitively. Any basically tells you if any of the item is true. If any of the item is true, hey, then give me the answer as true. It's just that. So that's the overall understanding. Let us just see the example as well. Any, okay, it returns true if any item in the list is true. So this one is true. So it's going to give you a true answer. Similarly, let us make L5. Let's say I have 1, 0, 0.0, then this empty string. We are going to learn tuple, so let me just add a tuple here as well. And let's say something like 0j. And if I do any here, any of L5, it's going to give me true. Okay, in a similar way, we can check if none is also true or not. So let us do this. Any L5, it is giving false. So it seems that none it is taking as true, or something else it is taking as any, basically it is giving as false, right? So return true if bool of x true, or any x in the iterable. If the iterable is empty, sorry, my bad. So it is false. Like any item here is not true. So this none is also basically your false only, right? So everything is false, nothing is true, right? So pay attention everyone. It checks if any one of them is true and gives you the answer as true. If all of them are false, then it gives the answer as false. The reason we are getting false here for L5 is because everything here is false right now. The second I add something here, okay, the second I add something here which is true, which is evaluated as true, it's gonna give me the answer as true. The second I make it false, so empty string we remember is false, again it's gonna become false. Okay, so that's the overall understanding about any. Now again, I think you can understand where this can be used in industry as well, right? These are like very day-to-day function which you use, right? So if you are actually working on them, it makes a lot of sense to use the inbuilt one only, right? So these are your, I would say, inbuilt function. The last one is all. So it is actually, I would say, very intuitive. Like if everything is true, then only it returns true, right? So we know that, okay, let me make an L6. Now let's say 1 is true. Then we have 1.5 also true. Then we have anything like this true. An empty string is also, a list with something is also true. Now if I do all of L6, it's gonna check, is there a false? If everything is true, it's gonna give me true, else it's gonna give me false. So see, everything was true here, so it gave me an answer as true. The second I add something which is seen as false by Python, it's gonna give me false. Okay, so whereas any were looking for just any one of the item which is true and returns you the true, all is actually checking that everything should be true. Okay, so this is just the difference, and again this is a very fundamental, I would say, operation, so you have to understand this very nicely. So all, any, sorted, I think all of them are clear. Okay, so please make sure that you rewind and see the video again if you have doubt anywhere. Okay, because all should be clear to you. Okay, cool. So I hope with that the functions are clear. Now these are the basic one which are used normally. Of course there can be other functions as well which can be used on a list, because list anyway, like you can create your own function as well, which you are going to see in the next, I would say, after once we complete these data structures. So now let us move to methods. Now before moving to methods, let me make sure that I explain you a few things about functions and methods. So function, we have seen that it is something like that, right? Fun, and we have a bracket where we pass this, right? So this is what a function is, right? We can have our own function as well. That is all good. We can create a function today, like let's say, which is maybe checking if 2 are true or not. Okay, very simple loop and something which we are going to also see in the future, like how we can create our own functions. So function is actually called on an object or a variable. So you were calling this function on L1, right? This is a function. Method on the other hand is something which needs your object or a variable to call. Okay, so let me write it variable here as well. It needs a variable or an object to call. And I think till now we have not seen how methods are called. So let me showcase that to you as well. 1 second. I think I added a new page. No, I added a overall new this only. So method and function in list, and yeah, we should be good here. Yeah, pay attention everyone. So extremely sorry for that. Yeah, so let me go on Edge and see. I have this L1 and it is fine. But this L1 also have some, I would say, inbuilt function. Maybe you can think of this for the time being as inbuilt function. And if I provide tab, you're going to see these functions, right? So it is needed L1 dot. So you need L1 to call these functions. They cannot be called without L1. So these are your methods, right? Now, how to create these methods? Like you cannot create methods which are, I would say, different than what all you can see on the screen. Like they are by default created for a data type or data structure. Okay. In the OOPS, we are going to get a lot more clarity on how we can create these methods. And if you will study OOPS from me properly, you can actually even create your own list, and there you can create these methods as well. But for the time being, we are going to learn about these methods very nicely. So further discussion and clarity on this will actually be given when we study OOPS, because methods are actually designed, I would say, kind of discussed and introduced there. But again, I want to make sure that you understand what all are the powers of your list, right? Because this functions though can be something which you can even write. But these methods are specific to a data structure, which you cannot write. Okay, everyone? So now let us try to understand methods. Again, very nicely, all the methods are, I would say, available and explained here. So this is also basically written here that, okay, what is a function and method. Now let us see the first method, which is append. So I have this L1, okay. Append, if you know, append is basically adding something, right? Append is adding something. So if I do L1.append, let's say 6, and I see L1, it's gonna add L1, okay, to my list. Now you can provide shift and tab here to see that what exactly this thing does. Shift and tab is actually your friend. It's going to give you the best overall, I would say, understanding. So append object to the end of the list. Okay. To make sure that it is a lot easy and clear to you, so these are all the methods which we are going to discuss: append, extend, insert, and all these 11 methods. Shift and tab are of course the best, I would say, documentation you can find, because that is the official documentation. Okay, but to make sure that they are a lot more intuitive and clear to you, you can just refer to this diagram as well. Okay, so let's say it is a circle, square, square, and if you append this triangle, the output which you are going to get, it's going to create a triangle. Okay, so let us see this L1. Okay, now again it added this L1 again, so should be fine. Now the next one is actually your insert, extend. Okay, extend. So what happened is, like, let's say, pay attention here. This is our L2 and this is your L3, right? So let us first do L2 dot extend. Okay, L2 dot extend, and press shift tab. Shift tab. Extend list by appending elements from the iterable. So if you will provide an iterable to it, it's gonna make sure that it adds everything there, to your list. Okay, so let's say if you have a list of all the orders which are placed, and you now want to append to it a list as well, like the way, if you remember, we used to do by concatenating, by adding them. That is what this particular operation does. So if I do this, okay, then my L2 becomes all the things in L2 plus the items here. And this is very analogous, if you remember, this is very analogous to when we were doing L2 plus L3. Now, of course, now I'm gonna get these 2 times, because L2 I have already extended it. Okay, so it is, I am able to see this 2 times. Okay, but overall the understanding is this only, like, it is basically make sure that it extend your list by giving an iterable. So if you're giving an iterable, that is going to get converted into a list, and or basically that's going to get appended. All the elements inside that iterable is going to get appended to your list which you are calling it on. And this is very important. See, I'm using L2 to call on it, so it's going to make the change in L2, not L3. Okay, our L3 is actually exactly the same still. Okay, so this is the reason, like, their method, because L2 is actually calling this method. Okay, so this thing I hope is also very much clear. Let me know in the comments if anything is not clear, and I will be more than happy to explain you. You can okay, extend is not there, but should be fine. Now the next one is insert. So we have seen append, we have seen extend. Now insert, okay, is used when you want to add to a particular location. Okay, so for that, let us just move forward. Insert. Okay, so what if you don't want to add in the last? Okay, so it is 1 2 3 4 5 6 6, right? Let's say, what if I want to add 0 in the starting, right? So what happened, L1 dot insert, if you see the documentation, insert object before index. Okay, so if I add 0 here and I add the object which I want to add, let's say 0. Now let's see this, let's see L1, and it's adding it in the starting. Okay, so just to understand this, what exactly happened, because this can be a little bit confusing, pay attention. So this is your list overall, let's say 1 2 3 4 5 and 6 6. So just you can think that this is the index, right? 0 1 2 3 4 5 6. So when I provided it 0, the document was saying that it add before that, right? So it added here only. So what you can think of it is that it adds the element which you are giving to that particular location and shifts everything towards the right. So for example, if I will add anything to 4, let's say if I add 100 to 4, this all is going to get shifted to right. This is going to get all shifted to right, and I'm going to get 100 here, and then 5 6 6. Again, this is very important if you want to add something in between of your list, right? In between of your list. So let me show you this as well, everyone. Just a second. Yeah. So L1 dot insert, let's say now it should be 5, I think, yeah, 0 1 2 3 4 5. So I'm just adding it here, 5. Okay, 100. And if I see L1, so see, it got added on 100, and the things are actually shifted here. The things are shifted here. So this 5 6 6, this got shifted. So that is like which location or index you want to add. That is what the first thing you say, and what you want to add is the second thing. Just one thing, of course, as list, like, the overall basics remains the same. If list is a heterogeneous item, then we can anyway add a string as well, and it's going to work extremely fine. Okay, cool, everyone. So I hope this is also clear. So we have seen 4 of these functions. So append, extend, insert. Okay, now let us see index. Okay, first let us try to understand this from here. So index, as you can see here, it gives you the first index of the number. So for example, it is very easy to understand. Now, you know that, okay, Mayank is at second index, like this is 0, 1, 2, right? But if you want to find that, what you can do is index, and you see it returns the first index of the value, right? So if you add Mayank here, it's going to return 2. On the other hand, if you add index 6 here, it's going to give you the first index. Okay, so this is 0, 1, 2, 3, 4, 5, 6, 7, 8. So it's going to return you 8, right? It's not going to give you 8 and 9. It gives the index of first occurrence. So the first occurrence of 6 is at 8th index. Okay, yes, 6 is available at 9th location also, 9th index also, but it's going to give you just the first index. Okay, so I hope this is clear as well. Now the next one is count. Count, as you can see, I think very easy to understand. So just give you the count. So L1 dot count of let's say first let me take it for 1. So let me show you the documentation. Return number of occurrences of a value, right? L1 dot count 6 is gonna give you 2 because there are 2 6s here. Okay, so again I will repeat it. Index just gives you the first occurrence index of the value which you're providing. Count gives you, on the other hand, count gives you that how many times that particular index element is occurring. Now let us try to find one more thing as well. Count, let's say 10. Okay, it's going to give you 0 because we see, if we can see this in our L1, we don't see that 10 is available. Okay, so again everything is very nicely explained here as well. So index returns the first occurrence of the value, then count is there. Okay, then of course if count is there, then we can have remove method as well. So pay attention everyone, remove. Okay, so what exactly remove does? Remove method removes the first occurrence of a specified value from the list. So the index, the occurrence, I would say the number which index returns, it just removes that. Okay, so let me just show you that. Let's say if I want to do L1 dot remove 1, so this 1 will get removed and everything is going to shift toward the right. Okay, L1. Now what's going to happen if I remove 6? Okay, let us see this. It's removed the first occurrence of 6. It didn't remove every 6 which is there. It just removed the first occurrence of the 6. Okay, so I hope this is clear. Let us just now again check this one thing as well. L1 dot remove 10, and it's giving an error because this 10 is not in the list. So you have to make sure that if you're running this 10, maybe you run it something like this. Maybe you run it. So to avoid this error, if 10 in list or L1, because we know that membership operator works equally fine in your list, then you can run it like this, and now it will not give an error because this will be false and we will not get this. And this is what I would say separate good programmers from bad programmers. Like, you know that where you can get an error, this thing is very important, right? So that's why I'm showing you this for cases where it is not normally shown. And if you will just do it something like this, then you can get an error. So anytime you are running your remove function, it's very, I would say good if you make sure that you first check that if that element is there or not. Okay, cool. So let us now go back and see pop. Again, pop is a very easy function. It just removes the last element and gives you that back to you as well. Okay, so for example, if I do L1 dot pop, okay, let us first see what L1 is. L1 is like this. So the last element is 6. It's gonna return this as well, 6. It's gonna pop just the last element. So let us see the documentation. Remove and return the item at index. Okay, so this return thing will be a lot more clear when we see function as well. But yeah, for the timing, you can see that it removes and gives that to you. Okay, that you can do anything. Not just removes, but also gives that to you. On the other hand, remove was not giving it back to you. See, L1 dot remove. If I do, let's say 4, you will not see anything here. It just removes that. It is not giving it back to you. Okay, so pop just removes the last element and gives that back to you. Now one thing again here to just check. Okay, let's say if I'm making L6 is equal to empty list, and if I do L6 dot pop, it gives an error because your list is empty. Now I hope you know how to solve this error. Okay, so if len of, let's say, L6 is not equals to 0, then you can basically pop it, and now you're not going to see the error. So again, this is a very small thing I would say which you have to make sure of. Okay, but yeah, that's going to be very helpful to you. So I hope each and every of the methods are a lot clear to you. Again, you have this particular full notebook. You have my notes as well. You have this very awesome diagram which explain it in a very, I would say, cartoonish and a very good way. Okay, so let us now move forward and see clear. So for clear, one second, as the name suggests, is clear your list. Okay, pay attention everyone. So let's say if your L3 is like this, if I do L3 dot, and because you are dealing with methods, clear, and then I show you, if I run it, and if I show you L3 now, it just removes everything. It just basically saying that everything from your list is removed. Okay. So it gives you, it basically reinitializes your list as an empty list. Nothing else it is doing. It can be useful sometime when, let's say, you are working on orders from 2 days back, and now you want your list for orders placed for the yesterday. Then you can just clear your list, right? So you still have the list, but now it is completely from scratch. It is completely empty. Okay. So now let us move forward, everyone. Next one is reverse. Okay. So pay attention. Let's say if I have L2, right? If I do L2 dot reverse, it will just gonna reverse yours on in place. So now L2 is reversed. Okay. So I hope this is clear. Now if you know indexing, everyone, you will remember this kind of a function, right? So this gives you back your list as reversed. Okay, so if not, then please make sure that you see this in the slicing video. Sorry, not indexing, slicing. Please make sure that you see the slicing video again in the Hello Python series, because as I said, this is very, very important. So if you understand this, this is in a way what this operation is doing, right? It is making your L2 is equal to the whole list reversed. Okay, L2. Yeah, cool. So I hope everything is getting clear. I know that it is a little bit, I would say, lots of things to digest. But yeah, once you clear them out, it's gonna be a lot easier, and you will just appreciate one thing as well, like all the operations, all the methods which are there, right? So they are there because we know that our list is, I would say, invertible. Our list is mutable. You can add things to it, you can remove things from it. That's why these elements are present here. You can reverse a list as well and store it back. So that is what your reverse does. Okay. Now let us see sort. Again, sort is very much I would say straightforward to that sort function which you were saying. So if I do sort L1, L2, pause the video here and tell me what's gonna be like. Think, you cannot tell me, so think what is gonna be the answer. Now if I run it, everyone, I think I'm gonna get an error. The reason is that it has ABC here, and sorry, my bad, L2 dot sort, right? See, this is not supported between string and int. So what I can do, L2 dot remove ABC, and now if I see my L2, it's fine, and now I can run this sort. Okay, so this is gonna give you this L2 in a sorted format. Now what if you want it in a reverse sorted manner? Like let's say this all, okay, this all is in a return manner. So if you will provide shift tab, there is a reverse which is equals to false by default. So what you can do is you can do L2 dot reverse. Okay, and what was the thing? So 1 second, sorry, L2 dot sort, and you can just provide this reverse equals to true. So now it's gonna reverse, now it's gonna sort, but it's gonna sort in descending order. See, everything is in descending order. Similarly, we have L1 with us. Okay, L1 is this. Now again, we cannot call sort here because Mayank is present here, and we cannot compare string to an integer. Okay, cool. I think yeah, we are just last with one. So copy is a little bit tricky, but I will try to make sure that it is clear to you again. Let us take this L1 only. Let us take this L1. And let me take L1 copy. Okay, so pay attention, everyone, like what exactly is going to happen here. Okay, pay a lot of attention. Now see, if I just use this equivalent, let me just write the heading here as well, copy method in list. Okay, see, if I have this L1 and I try to make an L1 copy is equals to L1 by this is equals to only, then you will see one thing. L1 is this. Okay, L1 copy is this. They are exactly the same because yes, we needed a copy. But what if I do L1 0 is equals to, let's say, 1 2 3. Okay, and I see the L1 now. Pretty straightforward. We know that list is mutable. You can change the overall, I would say, whatever is there in your list, you can change it very nicely. So the first element is going to become 1 2 3 instead of 0. That is fine. But what's going to happen in L1 copy? Does it going to change or not? Pause the video and think on this once. Okay. Well, the answer is that yes, it's gonna change. The reason for that is like you can think of this in this way. Like let's say when you copy, like when you use this equal to sign, now the address where list is stored, that is actually copied back to your L1 copy variable. Okay, the L1 copy variable has your address of L1. Okay, so how I can explain you that? Just pay attention. Okay, yeah, cool. So see, let's say L1 is made somewhere here. L1 is made somewhere here. Now when you do L1 copy, let's say the address was 0x123, something like this. Both are now pointing towards the same thing. it's exactly the same. Let's say if I tell you like, let's say if I know the location of, let's say, India Gate. Okay, it's in Delhi. Now you take the address from me of India Gate. Now I go there and make some change. Now if you will also go to that India Gate, right? If you will also go to India Gate, you will see that change, right? You're gonna see that. Let's say if I have written something, although we should not write on any monument, but if you go there, you're gonna see that that change is still there, right? So the understanding is same because you have the address overall, because you have the overall address. It's gonna basically make sure that it is the change is there as well. Okay, so this thing is where what happens in element.copy, and I can show you this very nicely, I would say, because this is an important, I would say, method. Let us use Python tutorial for that. So let's say if I make L1 1 2 3 something like this, and if I make L1 copy is equals to L1, and if I visualize the whole explanation, see. So okay, we can just, I would say, 1 second, yeah. So there was a way I can show. So let me just go to next. Okay, and what I can do is, 1 second, I was just showing that if I can use the overall. So see, L1 and L2 both are actually placing at the same location, right? So they are both basically saying that we know that where India Gate is. Okay, so L1 is like, okay, India Gate may 5 items are kept. I go and change one of the items. Now you will also go via L1 copy. You're also gonna go to India Gate only, and you're gonna find this thing, right? So this is the overall, I would say, thing which happens here. This is the overall things which happen in this. For this use case, we have this copy item. So you will see copy. Okay. What this shallow and deep, shallow copy is, and there's another one is known as deep copy. So I'm going to tell you that should be fine. But for the timing, what it does is, so let's say if I make L1 copy 2, and if I make it via L1.copy, okay, if I make it like this, then pay attention what's going to happen. So L1 copy 2 is this, L1 is this, but if I make, let's say, L1 of 0 is equals to 4 5 6 like this. Okay, now L1 we know it's going to change, L1 we know is going to change, but if I do L1 copy 2, it is still 1 2 3. Okay, so this has not changed, this exactly has not changed. Now again I can show you the same here as well, and then copy 2 is equals to L1.copy. So I hope this is a lot useful in understanding exactly. So pay attention. L1 copy, see, it is not pointing here. It is pointing to another list. Okay. So it is pointing to another list, not pointing directly here. So this thing is very, very important to understand. Okay. So this is where this copy is getting used. So now if you make some change here, L1 copy, because it is pointing there only, it's fine. But now because L1 copy 2 is pointing here, okay, this is a different thing. So if you make change here, it's not going to get reflected here. So that is where I would say the overall use case of copy is. Now these methods are pretty straightforward, like they are actually like this. I have explained you more than what is required, honestly. Again, you have these things, you have the questions as well. So please make sure that you do these questions without seeing the solutions. So just first see the questions and then do the solutions. And you can refer any W3 schools or anything. Here, just as I said, just the definition is given. No one is gonna give you this much. So let's say the copy just returns a copy of the list, right? But yeah, no one is going to tell you exactly what the difference is. So please make sure that you see this again. I know this is a little bit complicated, but I hope I've explained you this very nicely with this example, as well as using this visualization. Okay. Cool, everyone. So with that, actually, we have completed the functions and method in list. I know it's a pretty long video, but again, I wanted to make sure that all these things here are a lot clear to you. Okay. They are, I would say, very helpful, very useful in clearing once. If you clear them once, then you will see the benefit. Like when we are going to discuss the future, I would say data structures now, you're going to see what exactly is the benefit. And because these are methods, many of these are going to be common for other data structures as well, right? Because they are also kind of in a similar line with list. That's why list is very important to cover. So yeah, if you're liking the effort, the everything, please make sure that you like this video, comment on this video if anything is not clear. Do also comment if everything is clear. I'm also a little tired by explaining you in this much depth and energy. Download all the content which I have there. I will give the link in the description or in the first comment. And yeah, please subscribe to my channel and make sure that you share this with everyone, because I'm pretty sure that if someone understands this one in this way, he's never going to forget it. Okay. So yeah, with that effort, I hope all these things were very helpful to you. Now let's meet in the next video and we are going to cover another topic on list. And yeah, till the end, I would say of 2-3 videos, you will have a very good, I would say, hold on the list data structures. Okay. Thank you very much, everyone. Let's meet in the next video. Thank you.